This video is part of the Commercial Building Electrical Design series. We're talking about lighting design, and we're going through different types of lighting sources. And this lecture, we're going to look at induction lighting. So just taking stock of where we are, we've gone through terms and definitions and for good ways through the sources now. Again, down to induction type lighting. So let's talk a little about the theory of induction lighting. So with this type of lighting, we have a tube filled with mercury vapor amalgam that we excite by producing an electromagnetic field at a very high frequency. And so this is similar to previous types of light fixtures, with the exception of there is no anode or cathode. We do the excitation by an electromagnetic field. So this EM field transfers energy into the mercury such that it creates a high intensity ultraviolet light, again, that we can't see. And this, as before, illuminates the phosphor coating with the ultraviolet light. And this is the part of the light that we do see. So here you see one of these types of fixtures. If we take a little closer look at the end, there's no anode or cathode here. We just have this ring, which takes advantage of Maxwell's equations, Ampere's law, and Faraday's law, and then it excites an EM field in here. That's what excites the mercury amalgam. So even though these types of lights have been around for a while, they still have not really reached their full market potential. You don't see them a lot, at least not regularly used. Not exactly sure why that is, because they do have pretty good characteristics, which we'll look at here, and in my opinion, they're fairly competitive even with the LED type lighting. So let's take a look at this lighting source now and some of its characteristics. As far as efficacy, induction lamps have efficiencies that are comparable to fluorescent lamps and mercury lamps. Typically, they're in the range of 65 to 90 lumens per watt. So not out of this world, but they are pretty good. Probably the spot where they went out pretty much against all other lamps is in lamp life. These lamps do have an incredibly long lamp life, probably due to the way that the use of the electromagnetic field to excite the mercury. There's no anode or cathode, so that probably gets rid of some losses there. And so these have been rated anywhere from 85,000 to 100,000 hours for use. Induction light fixtures will typically experience some minor depreciation from all the different types of contributing factors to the light loss factor. All said and done, they're usually in the range of anywhere from 70 to 90%. If we look at the power spectrum distribution, we see that this is actually pretty decent. We have pretty good coverage across the color band, with a little bit of exception in the red area. It's not quite as well represented there, but most other colors seem to have pretty good representation. So it's usually considered to be pretty good. Just like with other fixtures, there's a lot of things that go into calculating coefficient of utilization. But when you use these types of lights, the parts that rely on the source, these are generally considered to be acceptable for induction type lighting. Some other fixtures might perform a little better in this area, but overall it's okay. When we talk about control, starting and restarting is excellent for these types of fixtures, and it's almost instant, but you probably won't find many of these types of fixtures that are dimmable, if that's an important thing for you. Induction lighting is generally considered a very good option for difficult to access spaces, such as those with unusually high ceilings, in that they have an excellent lamp life or expectancy, so you won't have to be coming in as regularly and changing out the lamps. So that is a big benefit to these if you have that type of application.